Welcome to math class. We are continuing on in the Math Makes Sense 9 textbook. Math Makes Sense 9. We're working on 4.5. So we are using graphs to estimate values. Probably I know I said last time I thought that the last section was the simplest one in the unit, but this one probably is. Yet this one also is going to help us better understand, hopefully, the relationship between x's and y's and why we use linear relations as a skill in the real world. So we're going to start off by looking at the example on page 192. So they have a graph here that shows the journey of a car. So heading this way, this is how many hours that you're driving for, and this way shows the distance covered. So if you look at our graph here, what it's showing is that as time goes on, my distance increased. The further I drive, more distance. Further I drive, more distance, so on and so forth. So what we're going to be doing is we are going to be using this to estimate or to take educated guesses. So what they're looking for is, based off of this graph, they want to know if we traveled for 1.5 hours, what is our distance? Now, we could start writing equations and calculating out based off of our speed and our time and those kinds of things, but instead what we're going to look at today is we're just going to basically take our best guess using the visual representation of our math. So what we've got to do is we have to find 1.5 on our graph. So I'm actually going to go ahead and blow this up a little bit bigger, so it's a little bit easier to see. All right, so I have to look for 1.5 on my graph. So I'm going to slide over here, 1.5, 2. So this is halfway in between 1 and 2. So that is 1.5 hours. Now all I'm going to do is look at where on my linear equation does 1.5 hours intersect. So I draw a straight line up until I touch my actual linear relation line. Now I'm going to look sideways, and I'm going to look, oh, my line there doesn't come out very visually representative. So my line there, if I look, is actually, let's draw a straight line, slightly above, oh, that one doesn't help either. Doing this on a smartboard isn't the easiest sometimes. Okay. All right, so I have to look, and I can tell already that if this blue line here is my 100 level, I know that this is a little bit above it. So what I'm basically going to be doing is taking an educated guess as to what that value is. I know that that is 150 because it's equal distance in between 100 and 200, which is 150. So I know this number is going to be less than 150. It's probably going to be closer to 100 than it is to 150. So I'm going to say that this is roughly, let's say, 120 kilometers. Okay? Again, we are guessing or estimating here, so it's not a huge deal if we're not exact. That's not what they're looking for. What if they're looking for, we have traveled, or they know that they have to travel 300 kilometers, and they want to know how long does it take? What is the time we're looking for? So we're going to do the exact same method, only we're going to be doing it from our distance side instead of from our time side. So I know that I've traveled 300 kilometers. I'm going to find that point on my y-axis. Now I'm going to go ahead and sort of drag this across and see at what point I intersect the line. So I intersect the line in between two of these nice points, or sorry, two of our nice little grids right here. So the point I'm going to try and draw my best and straightest line right down into the middle there. So it crosses the x-axis, or our time axis, in between 3.5 and 4, a little bit closer to 3.5. So, well, roughly. I guess if we look back up here, I know that it's probably in the middle. So let's go ahead and say that this is about, so it's 3. We know that it's not 4, but it's more than 0.5. So let's go ahead and call this 3.75 hours. All right? 3.5, 4.0. This is a nice healthy guess right in the middle, so we're going to go ahead with 3.75 hours. We'll do one more. What if, and this is where we have to make sure that we're doing our graph skills, what if they ask us to travel 450 kilometers and they want to know how long that's going to take? We have a problem. I don't have a 450 on this particular side of the graph. So what I have to do is basically extend this line up as best I can. If it's easier for you, you can rewrite it in your notebook. And then I'm going to simply make marks. So this is 350. This one's going to be 400. Okay, I'm going to go up a little bit more. That's going to be 450. And then 500. I also have to extend this line as straight as I possibly can, because I know that if I'm going up above my y-axis over here, then that means that this line is probably going to have to be extended, because I have to get all the way up somewhere in this neighborhood just to be able to cross my linear relation line. All right, so I've extended it out. You can redraw it in your notebook if that's easier. So I'm going to go ahead and start dotting across and figure out at what point do I intersect. Sorry. The other thing I have to do, I forgot to do this before, I have to extend out my bottom line as well here. So this is 4.5. Call that 5. 5.5. Call this one 6. 6.5. Call this one 7. Yeah, we'll say that that one is 7. So what we're looking at here is the point where roughly our line starts to intersect the linear relation. Now we're going to come down and see at what point on our other axes does it cross. It crosses roughly halfway between 5 and 6. So I'm going to go ahead and say that this is 5.5 hours to travel 450 kilometers. Okay, so that's our basic example of how we use our graphs to estimate values. Let's go ahead and look at the example on page 194. All right, so this is Maya, who is a jogger, and she jogs at, or sorry, this particular graph shows the speed, or the time in which she jogs and how far she's able to get in that time. So what we want to do is figure out how far does, or we want to use this, to predict how long it will take Maya to jog 2,000 meters. So I'm going to show you how we can essentially rebuild a graph in our notebook. Okay, so we're looking at this graph, and they have all the way up to 10 minutes and 1,200 meters. Now, the question they're asking is, how far is it going to take? They're asking us 2 of them, but they want to know how long it's going to take to run, not 200, sorry, 2,000 meters. And they want to know how long it's going to take, or sorry, how far she's able to go if she jogs for 14 minutes. Both of these pieces of information cannot be estimated on this particular graph because it's too small. We don't have the values we need. So what I need to do is go ahead and redraw this in my notebook. This is going to be sort of quick. It's not exactly perfect because I'm doing this on the smartboard, but you can do this a little bit tighter and neater in your notebook. So what I'm going to have here is I'm going to redraw in my notebook, and I'm going to go ahead and make, they've got 1, 2, 3, 4, 5. So this is how many checks they had on there. I'm going to go ahead and add, you know, let's get rid of this. Okay. So I'm going to add a few more spots on there. All right, so we've got 1, 2, 6, 7. I'm going to keep going up. 8, 9, let's call that 10. Mine aren't exactly spaced out, but if you're using graph paper in your notebook, this should be really, really easy to set up. Same thing here. I'm going to start moving mine across. 1, 2. All right, I'm going to start assigning these some values as well. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. You have to be able to recognize the pattern that they're setting up in theirs. And the easiest thing to do is follow the same pattern on yours. So I'm going to go ahead and look at this. We've got 200, 400, 600, 800, 1,000, 1,200. I'm going to keep the pattern going up 200, 1,400, 1,600, 1,800, 2,000. And so what I have now in my notebook should be a graph, a laid out graph with my distance, my time set up. Now what I need to do is look at this original graph. So it starts very easy at 0, 0. So I'm going to make my own point on my graph. 0, 0. I need at least 2 points, so I'm going to look for another spot on the graph where it passes through a nice, easy spot to remember. I've got one right here. Right, where I have 5 minutes and 600 meters. Okay, so I'm going to go over here and I'm going to find 5 minutes and 600 meters. So it's in between my 4 and my 6. 600 meters is relatively right there. I'm going to find a third point on this line. So I'm going to go ahead and use the end one here. So I have 10 minutes and 1,200 meters. So I'm going to find 10 on my graph, 10 here. I go all the way up to 1,200. And I wind up putting on a point right about there. And my graph is a little bit ugly, so this demonstration might also be a little bit ugly, but what I want to do now is using a straight edge, so a ruler or 1.6 meters, something like that. I'm going to try and connect up all 3 of these lines. As you can see, mine aren't very perfect. And I'm going to extend that sucker off right up into the heavens if I can. Okay, I need to get myself lots of room to estimate. Once I've redrawn a graph with more potential information on it, now I can go and look at what are they asking me for, right? I'm going to go ahead and bring this one down a little bit. Okay, what are they asking me for? So as we talked about briefly, let's actually do this one. Sorry, didn't mean to do that. Let's bring this one up here. So what they're looking for was, how long is it going to take to run 2,000 meters? So I'm going to do the same method I did for the last time. I'm going to come over to my newly drawn graph. I'm going to find 2,000 meters. And I'm going to do my best to bring a straight line. Ooh, that's not a very straight line. Over to the point where it starts to cross our line on the graph. I'm going to take this and I'm going to extrapolate this one down. Yeah. All the way down. As you can see, mine isn't very good. Yeah. I'm going to say that on my particular graph it was 14, or in between 14 and 16, so probably somewhere around 15. My graph is poorly drawn though, so let's not take this as gospel. You should be using graph paper in your notebook, which means that all of these points are going to be equal distances, which makes this graph a lot more accurate. Drawing graphs the way that I just did it here is not necessarily the best way, but it's for demonstration purposes. In your notebooks, you should be using graph paper. Okay, so roughly for my graph, it shows about 15 minutes to run there. Okay. The other side of it is I need to know how far will she run in 14 minutes. So I'm going to do the same thing here. I find 14 on my graph right here. Start drawing my straight line up to where it crosses, and then I'm going to run my straight line across this way. So I get about 1,800. Okay. There's a couple skills going on here with this particular unit. One skill is understanding the relationship between my x values and my y values, right? How do I, if I know my x, how do I figure out my y and vice versa? And then the second skill is building good graphs. You won't really get these answers correct on the assignments if you're drawing poor graphs. if your graphs are inaccurate. If you draw graphs like mine, you're going to get some answers that are wrong. But hopefully that gives you at least an idea of how I can build or redraw a graph in my notebook. Okay, but let's look at one more example before we cut her short today. I know I'm running a little bit long, but what we want to look at is what happens if we have graphs with XY coordinates. Our method doesn't change at all, but a lot of times people get confused. As soon as we start talking about X's and Y's instead of hours and minutes, few people get lost. Okay, so this example is from page 195. What they want is they want to know the X value if Y equals 3. Okay, so if Y equals 3, they want to know what the X value is. They also want to know what is the value of Y when X equals 5. Okay, when X equals 5. So we have a couple of things to do here. So we have to recognize, well, once we start doing it, so let's go ahead and start with our first one up here. Right? So I don't have an X value, so that means I'm not going side to side first. Okay? I need to be looking at my vertical axes. Okay, so my up and down. So I'm going to go ahead and count, go up 3. 1, 2, 3. So this 3 is over here. I need to dip it across and connect to this line. You'll notice this graph that I've drawn is a little bit too small. You're going to have to redraw, and I'll show you an example here. You're going to have to redraw the graph in your notebook so that it looks something like this. Okay? You can see that they had to extend this line over down this direction. They counted 1, 2, and 3, dragged it over here. They found where it crossed the line, matched it up to the x-axis, and they figured out that x equals -6 when y equals 3. All right, so that's how they do that one. Let's go ahead and put that graph away for a second. So let's look at our other pair here. If x equals 5, what is our y value? So I'm looking on my horizontal axis at the time, so I'm going to find 5. 1, 2, 3, 4. So 5 is right here. Start drawing up. You know what? Maybe I'll get rid of my drawn on line here. Okay, so it crosses the line. In between, it looks like 6 and 7 on the y-axis. So it crosses right there. So I'm going to drag it across and see. Sure enough, it does in between 6 and 7. So I'm going to estimate this value, and I'm going to say that this is about 6.5, right? So that gives us a final value of when x is 5, that means that y equals 6.5. Okay. So there we have it, a couple of skills. How do we estimate values, and how do we rebuild graphs with nothing but a drawing? See you in math class.